As we begin 6.4, I want to go back and look at a couple of those special factoring properties because they are going to become a very important part of today's lesson. So in the past, we have always said that if you have something like this, it really means that you have two quantities that are exactly the same, and this was a FOIL problem. So when we took the first two, the outside, the inside, and the last, we're going to get a very specific pattern of this. And the key pieces right here are that you have your base, you have 2 times each of those bases, and you have your other base. Now, the beginning and the end of those bases are raised to powers. If we look at a real number example, like a plus 3, the quantity squared, we could FOIL this out and have a plus 3 times a plus 3, but what I would like you to be able to begin seeing is that this 3 is really your b, and I could go straight to this pattern of saying the square of the first thing plus 2 times each of the things plus the square of the last thing. And that basically condenses this piece right here, and so I end up with a squared plus 6a plus 9, where I still have a perfect square in the front and the back, and this is twice the product of the bases. Now what this lesson is going to hinge on is the factoring piece, to recognize that any number that is built like the square of the first plus or minus 2 times the two bases plus the square of the last will always factor into that quantity squared. So let's look at another example. If I have something like k squared minus 4k plus 4. Let's see if we can rewrite this as perfect squares. Well, I would have k squared minus, I'm going to skip that, plus 4 is 2 squared. So now I see my base is 4 and 2. What's this in the middle? That pattern of 2 times the base times the base. Is that 4k? It is. So that means that this thing, without trial and error, will factor into k minus 2, the quantity squared. Why will we want to do this? Because I can undo a square with a square root. So this is actually going to provide us with a bit of a shortcut to solving. So let's go ahead and look at the actual lesson. So this is called completing the square. And that square we're talking about is a plus b, the quantity squared, or a minus b, the quantity squared. And we are going to be building this back number so that everything packs back into that quantity squared. So, a couple of problems. X squared plus 14x plus 49 equals 64 using the square root property. Now we could go ahead and we could factor this and we could get the answer. And I'm going to go ahead and do that because the factoring sometimes works. So I'm going to subtract 64 from both sides, and when I do that I get negative 15 equals 0. I'm going to factor. Plus minus means I have one of each. What are the factors of 15? That when I subtract I get positive 14. That's obviously 15 and 1. Zero product property says that x plus 15 equals 0 or x minus 1 equals 0. So x equals negative 15 or x equals 1. That's one way to do this problem. Now I'm going to show you how to use the square root property. Now a square root property is that idea that you can take the square root to undo a square. So when I go back to my original, what I see is a perfect square in the beginning and the last. So my question is that middle, because remember this guy is going to become a squared plus 2ab plus b squared, and this guy becomes a squared minus 2ab plus b squared. Does this middle piece right here match either one of my patterns? Well, I certainly can write that as 2 times 7 times x plus 7 squared equals 64. That means that this part here with the plus will factor into this pattern. It actually becomes x plus 7, the quantity squared. Notice I use just the bases, I don't include the powers, equals 64. How does this help me? Well, how do I undo squaring? I can square root both sides, and since this is a quantity, those two are going to cancel, and I have x plus 7 is equal to the square root of 64, super key, plus or minus 8, because remember, negative 8 squared is 64, and positive 8 squared is 64. And so if I take the square root of 64, I don't know which one of those two options I'm getting. Now, what does this mean? This means I have two problems. It means I have x plus 7 is equal to positive 8, or x plus 7 is equal to negative 8. When I solve these, subtract 7, x equals 1, or subtract 7, x equals negative 15. You'll see I get the exact same answer. It's just another tool for doing the same job. Irrational roots. Now remember, a rational number can be written as a terminal or repeating decimal. Irrational numbers cannot be written as terminal or repeating decimals. They are the ones that go on for infinity, like the square root of 2, like pi. So what we're going to do in this situation, when you look at this one, if we try to factor it, x squared minus 10x, subtract 12 from both sides, plus 13 equals 0, it doesn't factor. But that doesn't mean that there aren't two numbers together that would multiply to make that trinomial. So we are going to do the completing the square process. So if we remember that x squared minus 10x, I want to get a blank here. So I'm going to subtract 25 from both sides. So when I do that, I end up with negative 13 on this side. Now I'm going to go ahead and find a new value for right here so that I can turn this into a perfect square quantity. Okay? And the way I do this, and I will go ahead and write all of these steps down for you in a minute, is I'm going to take 1/2 of that middle number, so 1/2 of b, so 1/2 of 10 is 5, and I'm going to square it and add it to both sides, because what you do to one side, you have to do to the other. So now this has automatically become x minus 5, the quantity squared, is equal to negative 13 plus 25, which is 12. Now I can go ahead and take the square root of both sides. So I have x minus 5 is equal to plus or minus the square root of 12. From the last unit, I know the square root of 12 is 4 times 3. So I have x minus 5 is equal to plus or minus 2 square roots of 3. I always want to do exact answers. So I have x minus 5 is equal to 2 square roots of 3, or x minus 5 is equal to negative 2 square roots of 3. Add 5 to both sides. X is equal to 2 square roots of 3 plus 5. That's one answer. Add 5. X is equal to negative 2 square roots of 3 plus 5. And we know that those constants and those radicals don't combine, and so those are our exact answers. So let's look at the complete the square process. And you have room on the margin to complete this. So step 1 is subtract C from both sides. Now remember, we are dealing with some sort of ax squared plus bx plus c equals 0. Or it might be some number over here. It doesn't matter. So the first step is to subtract c from both sides. Second step, take 1/2 times the b value, leave the variable off, square it, add it to both sides. So now we're looking at this value. And what you'll see me do is I will write something like this, ax squared plus bx plus, and then I'll leave a gap equals that number that we had over here from our subtraction plus, and I will physically write a gap. And this is where 1/2 of b squared goes. Now what we've done at that point is we've guaranteed it will factor into a plus or minus b, the quantity squared. And the plus or minus is determined by that number right there. If it's minus, it's minus. If it's plus, it's plus. Then we're going to take the square root of both sides. Remember plus minus. And then solve the two equations. So let's look at an example. So here we go. This one is asking what c value needs to go in there. So really that's the 1/2 b, the quantity squared. So if we have x squared plus 16x plus some value, what would it be? Well, here's b. b is 16. So if I take 1/2 of 16, I get 8. I'm going to square that. And notice I don't actually write 64. I'm going to write 8 squared because then I can clearly see this will factor into this. Don't believe me? What is x plus 8 times x plus 8? X squared plus 8x plus 8x plus 8 squared, just to keep it clean. X squared plus 16x plus 64. And you can see that those are indeed the exact same things. I will continue with the rest of examples in part 2.